Hello everyone. Today we're going to get started with Arduino. You're going to learn what the Arduino is, how to code on the Arduino, and have some idea of how you can use the Arduino to construct your cyber-physical system projects. Let's get started. There we go. So, what is an Arduino? First, you should know it's a board. It's essentially a $30 to $35 computer in which you can collect data from sensors, you can send commands to actuators, and you can use data to perform some simple functions, as you've seen in some of the projects that have been presented in class. It can be powered by USB or externally with a wall wart power adapter. So you see a schematic on the slide, and here in the webcam I'm going to show you the Arduino in your kit. So you can see in this holder you have the Arduino, this teal colored board, and in addition to that we also have a breadboard which can be used to prototype different electronic circuits. Some of you have a red board, which is a special Arduino from SparkFun, but it is also an Arduino Uno and operates exactly the same way. Besides the hardware, there's also a software component. You can code your Arduino by writing up your code in what's called an integrated development environment. This is a special text editor for Arduino, which works just like any other text editor, except it has the special function of uploading your code into your Arduino. As you'll soon see, the Arduino programming language is something like BASIC or C++, but frankly even simpler. So if you're already familiar with MATLAB or Python, you're going to find it super easy to use. We'll talk more about that later in the lecture. Besides the hardware and the software, it is also a community. The Arduino is really at the center of the so-called maker movement. What is the maker movement? The idea of the maker movement is anyone, they need not have an advanced degree in engineering, but anyone can innovate creative solutions to solve societal problems. What's great about the Arduino is that it's cheap and easy to use to prototype these ideas. And because there's a worldwide community on this, it is super easy to search the internet and find some resources and ideas of projects or how to do specific things. So I'll give you some examples by going to my web browser right here. A really great website is Instructables. There's many awesome projects that you can search here, along with bills of materials and codes that you can use in your projects. Another great website is SparkFun. SparkFun is a website where we source a lot of materials for our projects, but they also have this Learn tab where there's many tutorials on how to do all sorts of different things with Arduino and the various hardware that supports it. Another one that I should point out is called Adafruit. Adafruit is a supplier for different maker parts, but it also has a learning category with a bunch of guides and tutorials on how to use various parts. Alright, so that's enough about the community. Let's talk a little bit more about the hardware itself. The heart of the Arduino is this Atmega microcontroller. So in the teal board, it's this long rectangular shaped chip that is essentially the processor and the RAM. The Arduino operates at 5 volts, which is important for understanding how you connect your sensors. It also has a number of input-output pins, so-called I/O pins. There are two types of I/O pins. There's digital pins and analog pins. In later lectures, I'll describe to you precisely the difference between digital and analog and how you can use that in your projects. For now, what you should know is that via this digital I/O pins or analog I/O pins, you are able to do data acquisition and also send commands from your Arduino. Now, just like a computer, it has memory for which you could store your programs. In our case, the Arduino Uno has 32 kilobytes of memory to store your programs. As you can see, that's clearly a very modest amount of memory, so you won't be able to have very large programs or collect a lot of data just with the Arduino board itself. You can also see it has a clock speed of 16 megahertz, which is sufficient to do some basic sorts of functions. However, you're not going to be running simulations or playing computer games on this hardware, or doing deep learning or anything like that. However, it is most certainly sufficient to power Internet of Things, for example. Let's talk about the software. So, the code is created in an Arduino-specific environment called the Integrated Development Environment, or IDE. It is basically a text editor for your Arduino. And as I said before, what's special about this text editor is you can upload the code directly onto your Arduino via USB. It truly is simple, clean, easy to use. I don't think I know of a text editor that is as simple and easy to use, so I think you'll find it very nice to work with. You can download it for free. There's a link on the screen here. I recommend that you do that so you can start your Lab 1 exercises. Alright, how do we connect the Arduino? Well, the Arduino has a USB port. In the case of my teal Arduino Uno, it's a USB-A. If you have a Breadboard, then it has a USB-B adapter. So I'm going to connect my Arduino directly to the USB port of my computer. Alright, and if it works, then you'll notice that there's an LED on the Arduino board that says on, which has lit up. So I know that I'm connected and I have power. Now the next thing we need to do is to open the Arduino IDE application. So I'm going to jump out of the slides and do just that. Here we go. In fact, let me close this up and search Arduino, open it up so you can see the flash screen here. Okay, so now I'm in the IDE. To confirm that your Arduino is connected properly, click Tools, and under Board, make sure that Arduino Genuino Uno is checked. This is the board that we all have in this class. Also, go to Port. Under Port, what you should see is something like USB modem. Perhaps it says Arduino Uno here. You want to make sure that that's checked so that your computer is properly communicating to your Arduino. Now, to check if everything's connected properly, what you can do, let me close this. Okay, looks like I have to reopen the IDE. If we close a sketch, then it closes the whole program. Okay, so I'm going to open an example. So if I go to File, Examples, Basics, and Blink, then I get this Blink example here. Now to check that everything is working properly, we're going to upload this code onto Arduino via USB. And you can do that by pushing this upload button here. You can see the sketch is compiling as shown on the bottom. It says uploading and then done uploading. If it says done uploading, then you know everything's connected properly. Let me show you what happens if it's not connected properly. Let me switch the port here for a moment. So you notice it's now on Bluetooth instead of USB modem. If I push upload, it'll compile upload. And it's going to have some issues. You can see some errors coming back. It'll keep trying. And you can see here it has some issues. Problem uploading to board. Okay, so I'm going to change it back. And now everything works as it should. Okay, so that is the Arduino IDE and connecting your Arduino board to your computer. Let's talk about the program structure. So in your IDE, where you write the code, every Arduino program requires two functions. Every Arduino sketch needs these two functions. It's required in every program. These two functions are setup and loop. So First, setup is a portion of commands that'll run the moment that you upload the sketch onto your Arduino. It runs once at the beginning. The commands in the loop function, those will run in an infinite loop continuously while your Arduino is connected, and of course after the commands in the setup function have run. You'll also notice that you can include comments. These are given by these forward slashes or forward slash with an asterisk. For those who are familiar with programming, and even if you're not, I'll mention that it is extremely helpful to include comments in your code for a variety of reasons. One, if someone else picks up your code and tries to understand what's going on, having some descriptions along with your code describing what's being done is extremely helpful. That's the first reason. The second reason is even when you look at your own code, it helps you organize exactly what's going on. So it's highly, highly, highly recommended, aka required, that you include comments to help organize your code. You also notice that some of the words, the syntax inside the code is color-coded. So for example, everything that's black is a variable or quantity that is user-defined. So for example, this variable LED is a user-defined name for an integer type of variable. We'll describe that next. But it's color-coded black because we define that. That's user-defined. In contrast, you have some syntax that is coded blue. These are constant types. So they're quantities, variables, but their value has a constant type. The next type of syntax is colored orange. Orange is used to denote functions or objects that are built into the Arduino language. So for example, you notice the setup function and the loop functions are coded orange because those are specific functions in the Arduino language. Next, let me highlight that we tend to call Arduino code sketches. These are the names for the files that we'll save in our IDE. And they're saved as .ino files. Frankly, I actually don't know the history of why they're called sketches. I think that's frankly an odd name to give to the code. And I also don't know the reason that the file type name is INO. If you guys know, let me know. I'd be interested to learn why. Okay, let's talk about how to declare variables. So first, what is a variable? Think of a variable as a box. It's a box where you can store data and manipulate it later. And there are various types of boxes: prismatic, cylindrical, so on and so forth. So all these aspects really are a good way to conceptualize what variables do. Now, first we need to define what type of box are we working with, what type of variable. So in the Arduino language, there's various data types, which really dictate what type of value is stored in that variable. So options include void, integers, characters, strings, and Boolean quantities. You can click on the reference page link to get more information about these different data types. So on the right-hand side, we're going to create a variable. It'll have the name LED, but it's going to be of the type integer, meaning the quantity that we assign to it will be an integer type. In the case shown here, the number 13, specifically the integer 13. Also, we need to give this variable a user-defined name. We would like these names to be unique and descriptive. And it should begin with a lowercase letter. So in this case, we're going to give the variable the name LED. It turns out that that is going to correspond to the pin that we're going to use to light up an LED with our Arduino. Next, we need to initialize a quantity into this variable. So in this case, what we're going to do is store the integer 13 in our variable with a user-defined name LED of type integer. Note that this is optional. It is possible to define the variable type LED and not yet put any data into it. Sometimes we call this pre-allocation of memory. In this case, we'll initialize it with a value, and in general, I think it's good practice to initialize our variables with values, which can be manipulated later. Okay, next, let me highlight the syntax of the equal sign. In programming languages, the equal sign does not have the same meaning as the equal sign in mathematics. In programming, it means assign to. So what the equal sign means here is that we want to assign the integer 13 as a value stored in our variable with a user-defined name LED of type integer. That's in contrast to mathematics, in which we would say the object LED equals the integer 13. That doesn't make any mathematical sense. Frankly, I find it a little bit frustrating because I'm a very mathematically inclined person. So we're overloading the notion of the equal sign. It does not say that the two things are equal on either side. What it says is we want to assign the thing on the right to the thing on the left. Also note that we will end each command with a semicolon, which indicates the end of the command. You'll note this is the same in MATLAB if you have experience in MATLAB. It is not the same in Python though. Okay, now let's talk about how to define a function. First, what are functions? Functions, just like in mathematics actually, are operations or commands that are user-defined, which will accept an input, perform some action, typically with that input, and then return data. So first, let's break down how we define a function in the Arduino language. The first thing we need to do is define a return type. This dictates what type of data is returned by the function. Is it an integer? Is it a Boolean quantity? Is it a string? So in this case, we're going to create a function called add. It'll add something together, but in the end, we want it to return an integer. So we'll annotate in front of the add function this Arduino defined syntax int to dictate that the return data is of type integer. Next, we need to give our function a user-defined name. We want it to be descriptive and unique. And just like variables, we're going to give it a lowercase letter. So in this case, I want to create a function that adds. So I'll just call it lowercase add. Next, we're going to define the inputs. So in this case, I want to make a function that's going to add two integers. So what you can see here is that in parentheses, I'm going to list the input types. The first one, we're going to give it the name int1, and it will be of type integer. The second one, similarly, will be denoted by the name int2, which will also be of type integer. Those are the type of inputs that I expect of my user-defined function add. Okay. Next, we will write what functions or what actions this function will perform. So what will happen here is we'll get the input variables that are passed into the function, and they've already been declared. And from there, we will perform some action on these inputs. So in this case, we're going to take the inputs int1 and int2, and we're going to sum them up. So what you can see here between the braces, which is the meat of the function, is I'm going to define a variable called sum. It'll be of type integer. And note that we do not initialize it, so we're just defining this variable of data type integer. And then on the next line, we will assign into the variable sum the summation of int1 and int2 semicolon. Okay, now that we've done that, we need to dictate what we're going to return, that is, what is going to be output from the function. So we're going to use the syntax return to dictate what we want the function to spit back out. In this case, we want to return the quantity sum. Some important things to note: that the name of the function will be followed by parentheses, and in those parentheses, you'll put the inputs to the function. The actions that the function performs are going to be surrounded by braces, these curly braces as shown on the right-hand side. The next thing to highlight is the function needs a return statement somewhere to indicate exactly what is being returned in this function. Another interesting aspect is in the Arduino language, no code is run after the return statement. So it is actually also, it also essentially indicates the end of your function. Okay. All right. So let's take a moment to examine the required functions in the Blink program. Remember, the Blink program can be found by going to File, Examples, Basics, and clicking Blink. Since it's already open, I just get the same screen. Okay. So first, you'll notice that we have some variables that are, in this case, declared before the setup and the loop commands. So these will be global type variables that can be accessed in the setup function and the loop function or anywhere else inside the program. So in this case, I'll define this variable LED of type integer and assign to it the value 13. Next, you can see that we have two required functions, as was described before, a setup function and a loop function. Now they are functions, so we need to define some output, some return. Now in this case, these functions won't return anything. So we'll define their output as type void, meaning nothing is returned. And because of this, the return line is optional. We do not need to include return lines in the setup and loop functions because nothing is returned, the output is void. Okay, now in this case, you'll also see that the setup and loop functions, the names are followed by parentheses. However, there are no inputs included in the parentheses. So there are no inputs to these functions. All right. Now, the action of the function is between these curly braces. So for example, in the loop function, which you can see is there are 4 commands that are run by these 4 lines. That will run in an infinite loop. And because nothing is returned, because the return statement on the loop function is void, we do not need a return statement. Okay, that does it for part 1 of this lecture on getting started with Arduino. In part 2, I'll begin to discuss serial communication. All right, everybody, welcome back. This is part 2 of our first lecture on getting started with Arduino. Now, I realize I failed to mention one thing in part 1 that I wanted to clarify now. Let's go back to the IDE and look at the Blink sketch. So I'll go to File, Examples, Basics, and Blink. Okay, so I have my Blink sketch, and now I'm going to upload the sketch onto my Arduino. Now, if you actually look at the code itself, what you'll notice is it's commanding to an LED attached to pin number 13 to turn on for 1 second and then turn off for 1 second. Now, if you examine your Arduino board, like mine right here, then what you'll notice is if you look at pin 13, which you can see is pretty close to the USB connector, you'll notice that there is a built-in LED on the Arduino that's blinking. That built-in LED is hardwired to pin 13. So you do not need to connect an external LED to blink an LED connected to pin 13. You can actually just upload the Blink sketch, and if it connects to pin 13, then it'll just turn this integrated LED on and off right on the Arduino board. Super simple, easy to use. Okay. That's what I wanted to mention. Now let's talk about serial communication. So, what is serial communication? The basic definition is it sends data 1 bit or 1 byte at a time over a communication channel. So, an analogous concept would be smoke signals. Imagine you're standing on a hill and your friend is on another hill. They want to communicate something with you. So they will send a series of smoke signals. The pattern of smoke with each signal might represent a word or a concept, and to understand everything they're trying to communicate, you will receive those signals one word or concept at a time until you understand everything they want to communicate. That is the exact same idea with serial communication, but obviously a lot faster. So, your Arduino communicates to your laptop via USB. That's what this connector does. However, your Arduino can also communicate with other external devices that aren't your laptop. For example, your Arduino might communicate with a Zigbee radio, which you'll do in Lab 1. Your Arduino might communicate with a GPS to collect information on your location, which you might do in a mobility project. How does it do that? It turns out that digital pins 0 and 1 are hard connected to the serial port. So you are able to establish serial communication with digital pins 0 and 1. That is something that you'll exercise with in Lab 1, Part 2. Okay, let's talk about writing software to do serial communication. The first thing we'll do is import this object called the serial object. What is the serial object? It's a package of both variables and functions that makes it easier to write code that uses serial communication. Easier in the sense that you do not need to use the lower level commands to access the serial communication channels. The syntax, you'll notice, will use the object name, in this case serial with a capital S, then dot, and then the function name. So for example, what you see here in the code is we'll use the serial object and then say dot begin to begin a serial communication at a certain communication rate, in this case 9600 bits per second. Then what you can see down below is another use of the serial object. In this case, we're going to use the function println or println, and the way this works is it'll take the content or the data that's in variable count, and whatever value is in there, it'll send as a character string into the serial communication channel. So that's what serial.println is doing. Okay, you'll also notice in this little bit of code, we are going to index the variable count. So it's initialized with the value of 0, and then in the loop, after we send the println command, we are then going to increment count by 1. So what you can see here is that count is being incremented by 1. Now, this command that says count equals count plus 1 is a great example to differentiate between the equal sign in mathematics and the equal sign in computer science. In mathematics, count equals count plus 1 doesn't make any sense. Completely false statement that is nonsensical. What it means here in computer science is that we're going to assign to the variable called count a value that is the current value in count plus 1. So it's really an assign to. Note that there's other syntax for doing this. You could say count plus plus or count plus equals 1. Okay, now as an aside, if you print the integer number 1, so for example, int 1 equals the number 1, and then you write serial.print 1, your computer is going to receive a character, the character 1. That is what's being communicated across the serial channel. It's characters, specifically these ASCII characters, even though you're giving to the .print function a into variable. Okay, now you might ask, how do we view incoming serial data? Let me jump into the into the IDE and show you how that works. So here I am in the IDE. I'm going to close the blink sketch, and there's a few ways to see to monitor serial information that's coming from your Arduino onto your laptop. You can go to Tools. Whoops. You can go to Tools and click Serial Monitor, and that opens a small window here for which you can receive serial communications. The other way to do it is on Mac, you can say Command-Shift-M, that opens the serial monitor, similarly on PC. The other way you can do it is in your sketch window, in the upper right-hand corner. In the upper right-hand corner, let me show it here so it's not in my face. You see a magnifying glass that says serial monitor. You click that open and you get the serial monitor. Okay, I have the count sketch here. You can see I initialize count to equals 0. I begin a serial communication, and then in the loop statement, I'm going to do a print line, which is the current value of count, sent as characters, even though count is type integer, and then I'll iterate the count variable by 1. So here I will upload the sketch, and now if we look at the serial monitor, we are receiving from our Arduino, it is communicating these incremented values of count. So the calculations are actually happening on the Arduino. We're just receiving this information, the smoke signals, if you will, from the Arduino across the USB, of course, but through serial communication. Okay, now let's talk about creating for loops. This is pretty similar to for loops in C++. It's a little bit messier than for loops that you might find in MATLAB and Python, but nonetheless pretty simple. So a for loop has 3 arguments. The first argument is the variable that's used to increment the for loop. So in this case, we are going to define a variable called count. It'll be of type integer, initialized at the value of 0. This is a variable that's going to be used to increment through the different iterations of the for loop. The second argument is a conditional statement. This conditional statement is what's checked each time we want to see if we continue through this for loop or if we terminate the for loop. In other words, we continue to execute the commands in the for loop as long as the conditional in the second argument is true. So in this case, as long as count is less than 10, we are going to continue to iterate through this for loop. The third argument is how we increment or iterate through our for loop. So in this case, we are going to increment the variable count by 1. That's what the syntax count++ means. Notice that we separate all these arguments in the for loop with semicolons. That's a standard syntax. And then what's executed in the for loop is inside these curly braces. Let me make a comment on best coding practices. Commonly, people consider it best practice to declare the counting variable, the incrementing variable, right inside the arguments of the for loop. Why? It's to make clear that this variable is specifically for the purpose of incrementing in the for loop, as opposed to defining it outside the for loop, as shown on the bottom, for which it's nebulous, not so clear, exactly how count will be used. Is it for the for loop, or is it for other things? They both work. However, it's best practice to declare the counting variable inside the function call of for. Let's talk about a different type of loop, a while loop. So a while loop is different from a for loop. A for loop will iterate a predetermined number of times. A while loop is different in the sense that it's typically when you want to iterate, but the number of iterations is undetermined a priori. And the way this is done is the while loop will receive as an argument some conditional statement, and we continue to execute the commands within the braces of a while loop, provided that this conditional statement is true. So for example, we have this variable count, and we will continue to execute the statements in count, provided that the variable count is less than or equal to max count. So this is how a while loop works. It is different than a for loop. Occasionally you can use one or the other. It's really up to you to figure out which is best for your situation. Now, different types of programming commands that you should be aware of are if, else if, and else. So these are statements that are executed if a conditional statement is true. So for example, if you look at this if statement, what it'll do is execute what's in the braces if the conditional inside these parentheses is true. So in this case, if count is less than or equal to 5, it'll do something within these braces. Else if, the way that works is if the statement with an if is not true, then it'll then look at the conditional with an else if. And if that one is true, then it will execute what's inside these curly braces. So on and so forth. Then if none of these conditionals are true, if it gets to else, then it just will execute whatever is in the else commands. Note, it may be possible that nothing is true inside these conditional statements. It also may be the case that you don't want to execute anything if any of the ifs or else ifs are true. So you don't necessarily need an else or an else if. This is just an example that shows all the different ifs, else ifs, and elses. Okay, let's talk about something completely different now. We have now talked about doing serial communication, and we have talked about the idea where the Arduino can send or receive information via serial communication. So what if we want to send data without serial communication? So because the Arduino is digital, essentially we can only send 0 or 1. That is 0 volts or 5 volts. That is low or high. This is the digital world. So how do we get an analog effect, some gradation between 0 and 5 volts with digital means? The answer is with pulse width modulation. And frankly, this concept is absolutely revolutionary. It is fundamental to electronics. What's interesting is if you pay attention closely, you see this idea used in things that are completely unrelated to electronics. Any case where you're trying to get an analog effect with digital means can use pulse width modulation. So here's the idea. So we're considering a digital language of zeros and ones, i.e. pulses. How do I communicate a value of 0.5 or 2.5 volts? One way you can do that is to say 1 half of the time and 0 the other half of the time. So the duration of the on time is called the pulse width or the duty cycle. And the idea is if you average saying 1 half the time and 0 the other half of the time, then on average that has the effect of 0.5 as described by this integral equation at the bottom. So if you integrated this pulse, that's a 50% duty cycle, if you calculate that integral, you'll get exactly the value 2.5. Okay? So this is how we can get an analog effect with digital means. This will play a role with the LED fading exercise that we're going to talk about next. So let's talk about a more sophisticated example of programming something on the Arduino. What we're going to do is try to fade an LED so that something a little more sophisticated than just turning it on and off. We're going to have the brightness increase and then decrease, and then increase and decrease. Okay? And we're going to use that with pulse width modulation. So let me now walk through how that works. Okay, so in this code, what we're going to do is initialize two variables, brightness and fade amount. The role of the brightness variable is it's an integer between 0 and 255, which indicates how bright we want the LED to be. 0 will be fully off, fully dark. 255 will be fully bright. Why is it between 0 and 255? I'll explain that in a future lecture. That sounds totally random, perhaps arbitrary. It is not. There is a fundamental reason why it's those two values. But for now, 0 to 255 maps to no brightness to full brightness. So that's the role of the brightness variable. What is the role of fade amount? Fade amount is essentially going to be how much we increment the brightness to change between dark and light. So it's going to be the amount that we increment the brightness variable. Also note that we are going to define the variable LED. This just indicates which pin that we're going to use PWM to actuate our LED. So let me take a moment and just highlight one point on the Arduino hardware. If you look carefully at the pins, you'll notice that pin 9 has a tilde next to it. The tilde indicates that it's a PWM pin. That is, you can send commands with pulse width modulation to get an analog effect through digital means. So we're going to use specifically pin 9. That's the one with the tilde next to it. Okay. All right. So now that we know what these variables mean, we know that we're going to actuate an LED connected to pin 9. We're going to set the duty cycle of the PWM pin connected to the LED. So the analog write command says, on pin 9, which is a PWM pin, I'm going to send a duty cycle corresponding to the variable brightness. Okay, so this will be a value between 0 and 255. Okay, now after I send that signal, which, note by the way, the first time I iterate through this, brightness will be 0, so analog write is going to send to LED pin 9. It's going to send the value 0, which is a duty cycle ratio that is 0%. So it's just going to be 0 volts the entire time. Now after we send that command, we're then going to run the command in purple, where we're going to change the brightness by a value of fade amount. So you can see we're going to increment the value of brightness by fade amount. In this case, it'll be a value of 5. So the first time we run this command, brightness will initially be 0. We're going to add 5 to that, and that'll be the new value of brightness. Now brightness can only exist between 0 and 255, so we need to do something when we reach 255 or 0. So that's what the next part does. You can see we have an if statement, and we're looking to see if brightness is less than or equal to 0 or greater than or equal to 255. When that occurs, we want the incrementing to change direction. That is, we'll redefine fade amount to be its negative value. So for example, if we are increasing the brightness by quantities of 5 points, once we get to 255, then we want to change fade amount to -5. In other words, decrease the value of brightness by 5 points. Similarly, when we get down to 0, it'll switch direction. So you can see how this logic works. Finally, we're going to have a delay of 30 milliseconds between each iteration through this loop. Note that the Arduino operates at 16 megahertz, so if we didn't have this delay, it would happen so fast that we couldn't really see anything. So that's why we have this delay of 30 milliseconds. Okay, so that's the LED fading example, and you're going to work more on this in homework 1, part 1, I believe. Sorry, lab 1, part 1. Okay, let's take a moment to talk about this breadboard. So that's this guy. What does it do? What's its purpose? And why in the world is it called a breadboard? That is such a goofy name. Well, let me tell you a bit about the history of the breadboard. So the first thing you should know is that a breadboard is used to prototype circuits without needing to solder anything. And before we had breadboards like we have today, and like what you have in your Arduino kits, what folks would do is they would actually take a bread cutting board, like from your mother's kitchen, and with thumbtacks and wires and batteries and what have you, will then assemble prototype circuits right on this breadboard. And it turned out to be just a really convenient way to prototype circuits. Now since then, people have thought about a more sophisticated and easier to use type of breadboard, and voila, you have the breadboards of today. So that's a pretty cool, interesting history on breadboards. So you want to use it when you want to prototype something because they're solderless. So it's easy to build a circuit super quick. However, because nothing's soldered, it's really not reliable. If you knock it over, then the wires might get disconnected. But it's really great for doing something temporary and quick. So it's great for prototyping. Let's take a moment to break down how the breadboard works. So the first thing I want to point out on the breadboard are these rails. These rails on the far left and far right. You'll notice that there are red and blue vertical stripes. The purpose of these typically is, suppose that you have a lot of electronic components on your breadboard and you would like to essentially have a ground and, for example, a 5 volts voltage supply. What you can do is feed ground and 5 volts onto those rails. And you'll notice that all the pins along these vertical rails are connected. That's very clear here in this picture, where you can see there's a conductor that connects all the pinholes on these vertical rails. Okay, so for example, if I wanted to do just that, so that is provide ground to the blue rail, I would connect ground from my Arduino to a pin on the blue rail. You can see that's connected up. So now I have ground connected on the blue rail. And I'll similarly do the same for 5 volts, which I'll connect to the red rail. Okay, so now I've connected these rails. So the blue one is 0 volts all across it vertically, and the red one is 5 volts all across it vertically. Okay. All right, now similarly, in the interior of the breadboard, all the rows are connected. That you can see clearly in the slides here. So on each side of the interior, all the rows are connected. Important to note. The last part of the breadboard to highlight is this ravine in the middle. What is its purpose? Well, it turns out that a lot of integrated circuits are in this package they call a DIP package. It stands for dual inline package. In fact, you notice that the Arduino ATmega microcontroller here is a DIP integrated chip. So this integrated chip we could actually put on our breadboard by putting it right across the ravine as shown in the picture on the slide. So that's the purpose of the ravine on the breadboard. Okay, so that really closes this lecture. There are plenty of resources to learn more about Arduino. For example, you can go to the IDE. If you go to File, Examples, there's all sorts of cool examples, codes, templates that you can use. Check out. They're really, really neat. You can also go to arduino.cc. That's the home website of Arduino. It has all the documentation for all the different commands and functions in Arduino. And then there's tons and tons and tons of great tutorials on websites like SparkFun, Adafruit, and Instructables. So with that, that closes this lecture, and I'll see you next time.